All right, let's see. Is this up? I always spend the first bit of the stream trying to get this set up properly. Okay, yeah. All right, great. This does look like it's working. Okay, so I'll yeah. Is this working there? All right, great. This does look like it's working. Yeah. Okay. Okay, so. Yep. All right. Let me just tweet this out, and then you can get started. Okay. Okay, cool. So let me just double check again where we were at. Yeah. Okay. As I said in the title, I'm working on the Python 3.13 compatibility today, and I've been working on this for a while, on and off. I've finished up some consulting projects recently, so I've got more time to do it now. And this has been harder than expected because, and I've talked about this on the tracker a bit, but there's a couple of different issues. One is with Pydantic 3, which I spent a bit of time on previous streams on, and the other one is Cython 3. So Cython 3 doesn't, the previous version of Cython doesn't support Python 3.13 quite reasonably. And Pydantic v1, the compatibility layer that we were using, also doesn't support Python 3.13, at least not the usage patterns that we were using of it. So the issue here is that these two things kind of intersect. So Cython 3 updates to this from future annotations thing, which means that type annotations are interpreted as strings. So this is a big semantic change in the way that runtime type annotations would work. It was some controversy and discussion around this between the Fast API and Pydantic communities and such, and the Python core development. And this ended up being sort of delayed as a compulsory move. But in the meantime, Cython went ahead and implemented this as the default and actually unchangeable semantics in Cython 3. So this means that there's this issue with using, with the way that Cython 3 interacts with Pydantic in the usage pattern that we have. And this ends up manifesting in the spaCy code as circular import problems. So when we import all over the library, you can't use the basically if type checking stuff, because what you end up with is, it needs to use that runtime. It's not just using that within the type checker. So if I switch over to the spaCy source, I can show you some more about this. So if we look within some of our, let's see, if I look at the tag, for instance. So what we have here is the default config settings for the tagger, then the factory, and then these registries. So these decorators end up calling into they call into the catalog registry system, and we want to move these things out of these PYX files, and then later we also want to move out these language.factory calls. And I actually think it's probably the language.factory calls more than the actual registry calls that are causing this the runtime access to Pydantic. But I thought, okay, let's start from let's sort of do this comprehensively and move it all out. So I actually started doing this with Claude Code on my laptop, and so I had this question of like, okay, what's the best way to actually show where I was at with that? So although this is a little bit odd, what I've done is actually stream I've started basically like a meeting between my laptop and this PC, so they can stream that, and so basically I can share that, do some things on the laptop, and then we can cut back over to the PC. So this is actually I always find it interesting doing this stuff with Claude Code, and this is maybe a good example to talk through. And maybe people in the chat will have suggestions for how I can do this better. Actually, speaking of which, I should actually get the chat up. So, yeah. All right. I'll also just write something quickly in the chat to. All right. So. Okay, so yeah, there's having made those couple of notes in the chat. All right, so as I was saying, I always find it a little bit interesting going through this because there's the models always change in their capabilities, and so the sort of optimal usage patterns change, and I feel like I probably don't get as much out of this as some other people. Like I haven't written extensive prompts for myself and that sort of stuff. But here's what I prompted for this. It's a refactor that I thought it made sense to do with Claude Code because it's a lot of mechanical changes across the code base. So even if this doesn't work perfectly initially, continuing to get better at these things is obviously going to be productive and just help me get things done across the library. I think it's important that I try to improve productivity as much as possible, given that we don't have a large team to work with on this. So all right. Here's what I started out prompting. So I prompted, in migrating to Python 3, the new from future annotations, semantic change causes circular imports due to the way we use Pydantic models. The problem is complex, but the solution we've identified is to move the declaration of functions into the registry out of the PYX files. However, to prevent backwards compatibility concerns, the functions themselves need to stay within the PYX. So what I'm talking about with that is I don't want the actual function implementations to move because I don't want the import locations to change, and because we don't have such a clear boundary around which modules are private, we expect some library users are using things at all layers of the interface, so we don't want these backwards compatibility problems from moving things around. So what I want to do is create a new Python module, spaCy.registrations, which will have a function populate registry. Inside this function, make the various registry calls. The register function returns the unmodified functions, so we don't need the assignment, only the side effect of calling it. The plan will be to have a global flag, registry populated, which will be checked and called before the registry is accessed. This will prevent population of the registry as an import side effect. Okay, so dutifully it says it's going to do it, blah blah blah. It goes and reads the files and etc. Then it starts to write out these changes. So it writes this the registrations.py file. This worked pretty decently. Then it goes ahead and says modifying init.py. And so yeah, blah blah blah. Okay. Now, right. So this is modifications to within the registry class, and I wanted this to do it more consistently rather than having these lines. I told it to make an individual function. Just call that blah blah blah. Then it goes and moves these things away and populates the actual function. Then it started going down a rabbit hole of calling these, checking for ensure populated and that sort of stuff in the out access of this when we were already doing that with the class. So I cut that off and stopped it from doing that. Now it's done the first draft, so now there's this sort of verification phase of it. So what I told it to do is run git diff and save the result to a temporary file, then edit the file, putting the addition of each registry line in the populate registry function together with the removal of that registry call into various files. The purpose of this is to ensure that no function registrations have been missed. So yep, it goes ahead and starts doing this. Then it finds that indeed there are things which I think it had things which were I think it found these as extra entries. So I think what happened was that these were registrations that didn't get removed within the actual files because they weren't in that bit of removing them from the files wasn't in the diff. So rather than go back and fix that, I told it, let's step back and since we made a mistake in the first time, we'll be a bit more careful before diving back into changes. Git stash the current patch and execute code to list the contents of the spaCy registry. Save this to a file and write a test that checks whether the registry contains these contents. This will later allow us to test our patch. Okay, so it goes ahead and stashes these. Then the first time it tried to do this, it did this nonsense where it was dynamically writing the test code. So that's like, to me, an ass backwards way of doing this. So I said, we want to output a JSON file or some other data file with registry contents. We'll write the test later to read in this JSON file and compare to live contents. So rather than dynamically generate both like the code and the data, we'll write out the data in JSON and then generate the test code. So here it generates the script where it will actually do that. Now we're at the stage of actually progressing with this. All right, so to continue. Yeah, cool. Okay. Yeah. All right. So let's see how it's done the test this time. This is where I need general instructions. I often need to tell it to use PyTest. So this is the sort of stuff which you're supposed to put in the more either project thing in the Claude.md, or maybe some even more global settings, because I never want to write tests that. No, this is also whack. Why are you making this execute main? But I guess that's okay. I can edit that. Yeah, no, this is okay. So we've got more edits here. Okay, this looks okay at first glance. Right. So, okay. Okay, before we run off and do that, let's actually run the test. So, do I have my other window up here? No. Okay. So, let's, is it something else? Okay. I think that's right. Yeah. Okay. Right. So, yeah. Okay. So first of all, let's actually look at this file that it created. Okay, so this looks correct. This is okay. Just registry contents. Just registry population. Okay. wait, so get status. So now we need to actually pop the current changes. So where are we here? Okay, so will we cause problems if we pop underneath this? Pop this. What's it actually trying to do here? Alright, let's tell it not to do that. Okay. Oh, I'm not sharing the right thing. Okay. Is there something else? I think that's right. Yep. Okay. Cool. So where are we? Why is this not working? Okay. What's happened here? Right. Okay. Let me just fix this. Okay. Right. There we are. Okay, we're back. Right. Yeah. So. All right. So these changes don't look entirely correct to me. Let's see. All right. The stream stuff got a little bit annoying if I. All right. Let's see. We'll let it cook for a bit and see how it goes. Yeah. So if this doesn't work after the next little bit, I think this is one where it sort of goes off the rails after it's been, what's going on here? Make entity ruler score, get any up, what? No, this is, okay, it's gone off the rails here. Let's exit this. Alright, so, should be, okay. Okay, so okay, so yeah, we're in the middle of getting this done. Now, yeah, I shouldn't have accepted those later edits. It started in the right place, but then if you interrupt it and ask it to go back to things it was doing, the results aren't good. Okay, so it's the best way to sort of fix from where we're at. So let's see. Let's try this. Okay. let's see whether this works. At least now we've got the test in place, so we know how this will go. Like we know we won't end up with a bug at the end of it. So the skeptic could well point out that it's far from clear that this that I've actually saved time doing it this way compared to how I would do to refactor otherwise. But I do think it's worth the investment of continuing to do this stuff, because I do believe I can get faster at doing it this way and using these tools, and getting the prompts right, and then also the LLMs will get better. Whereas I don't really think I can get that much faster at doing these things with with the way I've been doing it for the last 15 years or whatever. Okay, yep, continue. So, as I was saying before, that the motivation or the impetus for this refactor comes from the circular import problems that we were seeing from Siphon and Pydantic 2. But whenever I'm hitting this sort of thing, and I'm seeing that the way to have done something before doesn't work with these new because of some new variable, I'm always looking to make changes that are they're kind of good in themselves. And I do think that there's a couple of reasons why I like having, I think it'll be nice to have the registrations actually centralized rather than, as in the decorative format. One of the big ones is actually that it'll be a lot easier to find where things, to basically track down the relationship between the location in the source for a function and the string, because there'll be one file where that'll be happening. So that's something which, when editing the code, or when working through the config stuff, I've sometimes had problems. And then the other one is just, in general, reducing import time side effects is good. I think it's going to be a good step towards trying to reduce the import time of spaCy, because at the moment when we import, we end up with doing this this population of the registry, which ends up being that we have to basically navigate all the entry points and import everything. So if we can start migrating away from that, and it'll be sort of a succession of other changes as well that'll be required, eventually we can solve this import time, which, at least on when you run this through emulation layers, like Windows for Linux and on Mac, it does take a fair while to import, which if it's import call, which I find unideal. It slows down the CLI in particular. All right, so yeah, let's continue. So yeah, after we've done these ones, we'll start looking at the language.factory calls. That'll also lead us to another change, which I think will be quite nice. At the moment, the defaults for those functions are only expressed in the config. And this was done because we had this problem of, in spaCy 2, of having defaults expressed in the functions and then being unsure when some default, where in the call chain some default is actually being injected. So we switched over to have no defaults across those functions. This was good in itself, but when we actually go to use the Python API for these things, rather than access things through the config, those functions end up being a lot less useful than I'd like them to be. So I would like to have those defaults expressed in the Python code so that we can get the Python API feeling nicer again. So in order to do that, I want to have basically tests which check the syncing of the config files and the function signatures. sometimes get asked by other open source developers, how we feel about, the open source code, in GitHub and elsewhere, being, all ingested by GitHub and other places and used to create these commercial tools like Copilot. And some people are annoyed by this because, essentially the open source isn't making money, and then these providers of these tools are making money. So I think the situation's quite different if you've licensed, or potentially different if you've licensed under GPL or AGPL. But, I licensed spaCy under MIT, and most of the Python ecosystem is licensed that way as well. The implications of that is that, it's totally fine and normal that people are making money off the code and using it commercially. So given, it is quite a tangential use, and I think it's certainly a transformative use that something's created that didn't exist before, that doesn't detract from what was there. In the end, it's tooling. So to me, there's this continuum between, if somebody just reads stats of these things and, uses that to produce vulnerability scanners, or uses that to produce linting tools or something, and then several steps along the continuum, and now we have, using that to train statistical models. I don't see it as so philosophically different, and certainly if I was worried about commercial usage of the code, I wouldn't have chosen the license that we did. Okay. All right. So let's tell it to run the tests, I guess. Is it a circular dependency though? Ah, okay. All right. Let's let it try that. This is one of the things where, arguably I should let this sort of loop without this intervention, but I still don't really trust it to just do things. I, do want to be involved in that. So we end up with this sort of busy wait of, click enter. Is this the future of work? Okay. Kind of neat the way that it broke up the tests. Yeah, it's the sort of thing I would have told it to do. Start, test a little bit first if it hasn't been working for a while. So while that's cooking, let's look at this other bit of the code. Alright, so over here. Alright. So yeah, these are the language that factory calls. So these are the other decorators. So these ones actually work differently than the ones which go into confection, and I think it's actually here that we're seeing more of an issue with this import logic. So let's just look at the factory decorator here. Right. And blah, blah, blah. Okay, so here we are. So now what we want to make sure, what we want to prevent here is dynamic creation of a pydantic model within this, within the call here. Because then if we have to dynamically create a pydantic model, then we end up with these problems. So yeah, dynamically creating a pydantic model means that we have to actually have access to all of the pydantic types at runtime, and that means that we get these import circles. So let's see, where's factory meta here? So this is a data class. So yeah, nothing here should be actually calling into pydantic. Validate. That's That looks suspicious at least. Arg names. You filled up get arg names. So that looks like something which is going to do the at least signature inspection. So let's look at that. Yeah, so it does inspect. That's something which could be causing problems at import time. Then let's see, where's this validator? Okay, pipe analysis. Right, so validate component attributes provided to a science required, etc. This is errors for invalid attributes and formatting. Doesn't check if custom extension attributes are registered, since this is something the user might want to do themselves for later in the component. Alright, so where are we here? Yeah, no, this is all fine. This is just, this validation logic. Okay. So it's still not too much that would cause problems. Let's see. Okay, let's switch back over. Okay, all right. So let's see what it's got to. Get examples, callback provided to the language. Visualize, script dummy examples. Did it not run this? looks like this has worked at least. Okay, so that looks great. Okay, so let's go back to Claude. So, yeah, I mean, happy to answer questions from chat. Sure. Okay. Okay. This is a problem. That's something that okay, so let's see. Yep. Okay, that's cool. Let's do that. Maybe this is something that I should have just done myself. Doesn't seem to get what's going on here. Ah, sweet. It worked. Okay, now let's try to test. Awesome. Okay, now let's let it start the refactor. No. Okay, let's see. Okay. Okay. So after I get the factory registrations done, I'll break for lunch. Then I'll move back over to. So this should make a sort of complete patch by itself that I can push, and I'll keep this on a separate branch. Then I'll go back to the Python 3 branch, merge this, and see where it's at in terms of fixing this circular import problems. Okay, so let's see. Attribute ruler function, make attribute ruler. Yeah, okay, this is good. All right. So if this doesn't work, if we still have the same circular import problems after this, the next level of change to look at is actually the schemas that we have to find, because those create pydantic models. So if necessary, we might have to change the way that the schemas are used. So either moving them within functions so that they're only created, so that they only subclass pydantic as a function, or if we need them as sort of types, which I think we probably do. The other refactor that we can do is to, instead of having them as pydantic models as the sort of main thing within the library, we can make those data classes that are used for like the within library type checking, and then create pydantic models from those things at runtime, and then make sure that those pydantic models are not created at input time. So with both of those things together, we should be able to make. There should be no reason why we have to create a pydantic model at input time, and that should remove the problem with the from future annotations semantics that Python 3 has introduced. Because by the time we've by the time we go to actually create any of these pydantic models, we've got all of the imports accessible. Okay. And so it's definitely unfortunate that it can't read the whole language.py. This is, some motivation to refactor that a bit and make sure that it's small enough that it can actually read it. That implementation is quite a beast. It's a lot, for humans working with it as well. But it's just, that's the main class and it does a lot, or one of the main classes. Okay. This ain't right. Yeah, no. Okay. I think I've let it go off the deep end too much, and it'll struggle to recover from here. Okay. So it's definitely wrong that there's 136. I think that's some sort of problem with the way that it's. Yeah, this looks more likely. What the fuck? No, that can't be right. Oh, I guess. Alright. It's just a hacky script to produce this one data file, so. But yeah, when they see it doing things like, wanting to monkey patch a script to get a different result, that's often an indication that it's attacking the wrong thing. So, okay, cool. Yep. All right. Stand there twice. Spent entity ruler, I see. Okay. Yes. Okay, so I'll correct these. Yeah, I definitely should have done this part of the refactor myself. It's just, yeah. Like it's such a simple direct change. And this one, it doesn't have so many of them. The registration one, the registry functions was annoying because it was, a lot of things scattered over a lot of files. But this wasn't so many, and it would have been pretty easy to just do cut and pasting. Alright, oh yeah, okay, so now it's, yeah, blah, blah, blah. Just see where we're at with, we're almost there. Yeah. Okay. So, yeah, we are there. Okay, we can tell it to stop. Okay, let's fix it. Alright. So, yeah. So here we see, yeah, everything looks good here. We don't have any left over. So let's run tests. Okay, what have we got here? Let's see, where was that monkey punch that we did? Yeah, okay. It's not ensure populated. Register factories. Same funk. what's going wrong here. Right. Okay. So restrictions. Right, so here we are. Right. Okay, so I think I'll break for lunch now. So just take a little while to compile, and then you can come back and make sure that the factories are migrated, and that this part has been done correctly, and then you can check these patches that the patch together, then move over to seeing whether it's solving the Cypher3 problem, and then if it's not, move over to looking at the Pydantic classes and schemas. Cool. All right, so I'll probably be back in like an hour. All right. Cool. All right. So yeah. Should I end this, or should I okay, I'll end the stream and then restart a new one when I get back. Cool. Okay. See you then.